Dear friends, happy to welcome you all. Myself, Dr.D.Anu, Assistant Professor of Chemistry, Sri Sharada College for Women, Salem. Here, in this video, we are going to discuss about molecular orbital theory. What is molecular orbital theory? Before going to see about molecular orbital theory, there are some limitations in valence bond theory, that is VBT. We know that valence bond theory of covalent bond is formed between the atom of molecule involves the overlapping of atomic orbitals which are half filled. If the orbital is completely filled, it does not contribute to bond formation. VBT also fails to explain the magnetic nature of oxygen molecule. To overcome these limitations, molecular orbital theory has been proposed by Hund and Mulliken in the year of 1932 to explain about the formation of covalent bond. According to molecular orbital theory, the atomic orbitals of an atom participating in the formation of molecule approach nearer to each other and get mixed up to give an equivalent number of new orbitals known as molecular orbital theory. Molecular orbital theory explains bond order, bond energy, stability, magnetic nature of a molecule. ஒரு ஆட்டமோட ஆர்பிட்டால அட்டாமிக் ஆர்பிட்டால் அப்படின்னு சொல்லுவோம். அப்போ மாலிகுலோட ஆர்பிட்டால் எப்படி ஃபார்ம் ஆகும்? When combining two atomic orbitals, it form a molecular orbital with a comparable energy. Postulates of molecular orbital theory. According to molecular orbital theory, when atomic orbitals combine together to form a new orbital known as molecular orbital theory. Here, two hydrogen atoms combine to give hydrogen molecule, which means one is atomic orbital of one hydrogen and another one is atomic orbital of another hydrogen combine to form a hydrogen molecule. The second postulate says that number of molecular orbitals formed are equal to number of atomic orbitals combined or overlapped. When two atomic orbitals combine to form a two molecular orbitals. Similarly, when four atomic orbitals combine to form four molecular orbitals. Only those having comparable energy will form molecular orbital. Oneness and oneness atomic orbital combine to form a molecular orbital. Similarly, when oneness and 2s atomic orbital do not combine to give molecule because there is a much energy gap between them. When atomic orbitals overlap to form molecular orbital are two types. One is the bonding, another one is the anti-bonding. The bonding means bonding molecular orbital have lower energy when compared to the anti-bonding molecular orbital. The bonding orbitals are represented by sigma, pi, del, whereas the anti-bonding molecular orbitals are represented by sigma star, del star and pi star. The axial overlapping of axial overlapping form sigma bond and parallel overlapping form pi bond. The axial overlapping means head-to-head overlap and parallel overlapping or a pi bond, which means the p orbital always overlap along the line perpendicular to the bond axis. The bond axis is known as parallel overlapping. Here, the sigma bond for the hydrogen molecule. One is atomic orbital of one hydrogen and another one is atomic orbital of hydrogen combined to give a molecular orbital. Here, head-to-head overlap. Here, head-to-head overlap is formed, so it is a sigma bond. The next is a pi bond, that is a parallel overlapping or sidewise overlapping. sidewise overlapping. The example for sidewise overlapping. Here one p orbital, and here also one p orbital, here also one p orbital. They combine to give two electrons in the bonding, and the anti-bonding remains unparalleled. Here the two electrons are sidewise overlap, so it is a pi bonding. Side-to-side overlap of two parallel p orbitals to form a pi bonding molecular orbital, and a pi anti-bonding molecular orbital remains empty. Let's see the atomic and molecular orbitals of hydrogen and hydrogen molecule. We already know molecular orbital tells about the behavior of molecule. For that, first we want to know the electronic configuration of that molecule. Here, hydrogen having atomic number 1, and its electronic configuration is 1s1. So 1 electron in 1 here, and this is another hydrogen atom. Here one electron is present. These two atomic orbitals combine to form a two molecular orbital, and two molecular orbitals are formed in the bonding molecular orbital, and anti-bonding remains empty. So before covalent bond formation, each electron is an atomic orbital. After covalent bond formation, both electrons in the bonding molecular orbital. The anti-bonding remains empty. How we can calculate the bond order? For any molecule, first draw the molecular orbital diagram. After filling electrons, we can calculate the bond order by using bond order equal to 1 by 2 Nb minus Na, where Nb is the number of electrons in bonding orbitals and Na is the number of electrons in the anti-bonding orbitals. Here I have constructed the hydrogen molecular diagram. Here the one is electron in one hydrogen, and here the one is atomic orbital of another hydrogen combined to give a two molecular orbital. In bonding, here two electrons, and in anti-bonding there is no electrons. So by using 1 by 2 Nb minus Na, the bonding is 2 electron, and anti-bonding there is no electron. So the bond order would be 1. Hence the hydrogen molecule is single bond. Next one is a MO energy level diagram for nitrogen molecule. Electronic configuration of nitrogen is 1s2, 2s2, 2p3. The filled 1s orbital of two nitrogen atom cannot take part in bonding as it is an inner shell electron. The 10 electrons, which means the outermost electron 2s2, 2p3. So for an N2 molecule, the total is 10 electrons are going to participate in molecular orbital diagram. While filling the atomic orbitals, this is for one nitrogen atomic orbital. This is atomic orbital of another nitrogen atom. The 2s2, here now focusing on 2s2. The 2s2 having 2 electrons in each nitrogen molecule. So here 2 electrons and here 2 electrons. These are all combined to form a molecular orbital. So the 2s2 is filled. Next comes a 2p3. So totally 6 electrons in p orbitals. Here 3 electrons and here 3 electrons. They combine to give 6 electrons in bonding. The anti-bonding remains empty. So by constructing the molecular diagram, we can calculate the bond order for nitrogen molecule. And the bond here bonding is 1, 2, 3, 4, 5, 6, 7, 8. So totally 8, and the anti-bonding is only 2. So 2. So totally the bond order for nitrogen molecule is 3, which means it is triply bonded. And we can also write the relative bond energy for nitrogen molecule. This is the relative bond energy for nitrogen molecule. Here 1s2 and sigma star 1s2, the electrons are filled. Then sigma 2s2, sigma star 2s2. Pi 2px equal to pi 2py. Here the equal to symbol represents the both having same energy. Sigma 2p is z. Then pi star 2px equal to pi star 2py. There is no electrons in the anti-bonding, so no electrons are noted here. And also sigma star 2p is z. Here also there is no electrons. Before we are so we discuss about monoatomic molecules. Now we are going to discuss about heteroatomic molecules. Here taken as a CO molecule, carbon monoxide. Carbon having the atomic number 6 and the electronic configuration is 1s2, 2s2, 2p2. And oxygen having the atomic number 8 and their electronic configuration is 1s2, 2s2, 2p4. So totally 14 electrons in CO molecule. Out of this 14 electrons, the 10 molecules, 10 electrons, 4 from carbon atom and 6 from oxygen atom going to participate in the molecular orbit. Electronegativity of oxygen is greater than that of carbon. Hence, the 2s and 2p of oxygen is placed below the carbon. By constructing the model diagram, we can calculate the bond order for CO molecule. The bond order would be 3. So C triple bond O. Bond order showing that carbon and oxygen atom in CO molecule are linked together by 1 sigma bond and 2 pi bond. There is no unpaired electrons, hence it is a diamagnetic in nature. The relative bond energy of CO molecule. This is the relative bond energy of CO molecule. Next, summary of molecular orbital theory. Atomic orbitals overlap to form new orbital called molecular orbitals. The electron in an atom are filled in atomic orbitals. Similarly, electron in a molecule are filled in molecular orbitals. The energy of atomic orbitals should be comparable. The probability of finding electron in between atoms is known as molecular orbital. The number of molecular orbitals formed is equal to number of atomic orbitals. The shape of molecular orbital is depend upon the shape of molecular orbital. So based on the above discussion, I have posted 2 questions. The first question, construct the molecular orbital diagram for fluorine, oxygen molecule and NO molecule. So before we have discussed H2 molecule, N2 molecule. So now you can try for F2 and oxygen molecule. And also I have discussed the CO molecule or molecular orbital diagram. You can try for NO molecule. Then also calculate the bond order for N2 and C2 molecule by using the formula N half NB minus NA. So these are all the reference books I have taken. Thank you.